The next session is Decoding Dart, and let's look at DartVM. So let's welcome Festus.
Yeah, hello guys. Forgive me if I make mistakes because I'm really jet lagged and I've not practiced my slides at all. But we'll see how it goes. So my name is Festus Olusegun. I'm a software engineer and a Flutter GDE. I've been working with Flutter since 2018, I think, since I found Flutter. So, funny story, right? I used to be an Android developer. That was 2017, 2018, thereabouts. And I used to be basically this skeleton, waiting for Gradle builds. You change a variable or something very, very small, and you have to wait for about 5 minutes, depending on the kind of computer you have, right? And it just takes a lot of time to get the Gradle to build. And one day I heard of Flutter, and I was like, okay, I should probably try this thing. And when I built my app with Flutter, and I made some changes, the next thing, I saw this little button with the lightning sign, and I basically tapped it, and the change was instant. And I was like, oh, wow, this is really cool. And since then, I've been really obsessed. This was how I was when I found out about how reload in Flutter. I was really mind blown. And since then, I've been really obsessed with hot reload. So I took some time to do some research around why does this hot reload, why does it work in Flutter? And what I found was that DartVM was basically responsible for this hot reload, and that's exactly why I decided to give this talk today. While I was researching on DartVM, I found a lot of things, a lot of big words, compilers, kernel, intermediate representation, snapshots, etc. And I felt, this is what I was saying. So some papers on DartVM with very complex, very in-depth explanations, and I felt, okay, how can I simplify this to people of my level, basically? And that was what basically gave birth to this talk. Just an easy or a simple way to basically explain the DartVM and how the DartVM works to everybody. Yeah. Yeah. So basically, the DartVM. Let's say in Flutter, for example, you have your source code in Dart, and you basically press the run button. What happens is your source code goes to it's called a Dart toolchain or the compiler, whatever I want to call it. And this thing has both a front end and a back end, right? This front end takes in the code, passes it, tokenization, does parsing, tokenization, and it gives us the IR, the intermediate representation. And this IR is what gets sent to the back end, which in this case is the DartVM. Right, the DartVM does a bunch of things. It does a bunch of components. GIT compiler, ALT compiler, it executes the code, it does garbage collection, and a bunch of other things. We're going to we're going to go in depth of the DartVM very soon. This is like a basic comparison with the JVM and the V8s. So the DartVM does a bunch of things: GIT compilation, ALT compilation, garbage collection, memory isolation, auto reload, etc. And so this is us basically going into the details with the DartVM. So in the DartVM, we have a bunch of components. We have the GIT compiler. First, we have the AOT compiler. We have the Dart runtime, the garbage collector, and the optimization and profiling engine. So we're going to go in depth into every of these ones, starting with the compilation. So start with GIT. So what happens with GIT is your code goes into the front end, as usual, and then it goes into the GIT compiler. The GIT compiler, which is GIT is just in time, it basically compiles your code as you need it. And this is exactly why the feature I've been obsessed with, hot reload, is possible because the JIT compiler compiles your code as you need rather than compiling it all together. And this JIT compiler is used in development mode where you need fast rapid feedback. So the JIT compiler was responsible for hot reload because when you press your hot reload button, the code is the changes you've made get injected right into the JIT compiler, and then you see the changes. Okay, the next thing would be the AOT. The AOT on the other hand, ahead of time compiler. So it takes the code, goes through the front end, passing tokenization, IR, etc., and then it throws this IR into the AOT compiler, which basically compiles your entire code base at once, rather than unlike the JIT compiler, which compiles it incrementally. And it also does aggressive optimization. And then you have your machine code, your binary. So the difference between the JIT compiler, like I said before, is used in development mode, while the AOT compiler is used in production mode because it does aggressive optimization. It compiles your code base all at once. So these are like some comparisons and recap between the JIT and the AOT. So compilation time happens for JIT at runtime while your application is running. AOT on the other hand, did I press something? AOT on the other hand, basically the code is compiled and bundled, and nothing happens in runtime. Your code is not being compiled in runtime. It gets compiled at once, and a bunch of other things here: app startup time, performance. You see, JIT is slower, since the code is being compiled in execution, unlike AOT, which is faster, as everything is already compiled and just ready to execute. Then performance, app size. JIT is typically larger, and AOT is smaller. And so these are some of the comparisons. And AOT is what was used in production, and JIT is used in development. Then we have the runtime system. Okay, so the runtime system has a few components. I call them components, but these are things we'll be talking about: a concurrency, the objects model, and then the garbage collector. So starting with the objects model. So in Flutter, as we all know, we say everything is a widget, but when you start writing your Flutter code, you notice that not everything is actually a widget, and that's because of the Dart language, because everything in Dart is an object, and all your values, your numbers, your strings, functions, everything are objects. Even null is an object. Class is a blueprint for creating objects. So this is basically the object model. Everything is in Dart is an object. That's basically what it is. And then now we have concurrency and event loop. What is concurrency? I guess I will just throw this question to the wild. Can anyone maybe tell us if they have an idea what concurrency is? Anyone? Just one person? Okay. Yeah.
Concurrency is like when you have two logic of code working at the same time.
Sorry, I can't hear you.
When you have two lines of two branch of code working at the same time.
Okay. Yeah, something similar. So, there are two things. There's concurrency, there's parallelism. So, concurrency is basically, being able to manage multiple tasks at the same time. Meanwhile, parallelism is being able to actually execute multiple tasks at the same time. So, we're talking about concurrency. So, for example, you have an app, just like a text app, and you can basically tap on the download button and the image is getting downloaded. And at the same time while this image is getting downloaded, you can also send a message. So these are two different tasks that are being managed at the same time, and they are not blocking each other. That is basically what concurrency is. So in Dart, we have two types of concurrency. We have asynchronous programming, and can anyone give examples of asynchronous programming in Dart? Yes, again.
Async await. Any function with async?
No. I mean, yes, that's part of it, but that's not the complete story. Any other person? Yeah.
Running API and during that time do other things.
Not the full story. I mean, yeah. There are basically two things when it comes to Dart. Yeah, good. Again?
No, it's fine.
Are you talking about event loop? Yeah?
No, just asynchronous programming in Dart.
Yeah, but you can use event loop or delays or futures, streams, delays.
I mean, yeah, event loop, that basically manages the entire event queue and all that. But asynchronous programming in Dart, we have two major things: futures and streams. That's it. That's basically it. I mean, and then concurrency, we also have multi-threading, if I could call it that. That is done in Flutter using isolates. We're going to go, I feel like everyone knows what future and streams are, no? Anyone confused about futures and streams? Yeah, seems we all know what futures and streams are. So we're going to go straight to isolates. Yeah, so in Flutter, your app runs in, should I call it a box? That, yeah, in a box called an isolate. So this isolate manages the memory, and this isolate also has its own event loop for, managing the event queue, the microtask queue, and the rest. And here, for example, we have the main function, painting, download button, everything happens all in the same isolate. But for performance reasons, I think there was a session from someone today. She spoke about profiling, I think dev tools, and she spoke about isolates. So let's say, for example, you have a very heavy task that you need to get done, and if you run this task in your main isolate, which your Flutter app is running in, it could basically make the application lag. Maybe you're downloading a massive file, something like that. So rather than downloading this massive file in your main isolate and basically causing this lag or this jank, you could just spawn a different isolate, call it a download task isolate. This isolate takes in the maybe a URL to the file. It downloads the file, and then it's kind of sends back your results. So isolates in that they communicate by sending messages to one another. They do not share memory. They do not, basically the isolates do not really know about each other. Let's put it that way. There's no shared memory or anything. And then now we have the event loop. So this arrow is basically a representation of your app's timeline. So when you open an app, right, and you close it, that's everything that happens within that period. Let's just call that the timeline. And a lot of things happens. You call your set states. There's a rebuild, a repaint that happens. You call. I'm going to use the download file as an example. Also, you're downloading a file. You're calling an API. All these things are events, and I'm using these shapes to represent these events. So there's something called the event queue. So everything you're trying to do gets on this event queue, and the event loop basically comes to the event queue and takes the latest events. It's kind of it does the processing of the events. Then, it comes back, takes the next one, processes it till the events are basically all done. For example, here we have a simple feature. This is just an example of an asynchronous event. Now we have something else called a microtask queue. So this microtask queue, it's basically, should I call it a priority queue? So if you need a task done before an event, you use a microtask queue. What happens is, your event loop goes to the microtask queue, processes everything there before then going to the event queue, and doing the processing too. So for example, this code here, we have a future, we have a microtask, and then a sync, just a print statement. So here we have the future coming first, then we have the microtask, and then the sync. But if you run this code, what happens is you get the sync task runs first, this runs first, then this, then this. It's because of the way the event loop kind of processes this event. Your synchronous task will run first, then the microtask, and lastly, your event task, which in this case is a future. And yeah, memory management. So in Dart, we have a GC, garbage collection, which from the name is just, garbage collection. What happens with, let's go back. So what happens is Dart kind of, the garbage collector, should I call it, is like a cleanup crew. So when you have trash, there is a truck that comes to kind of take the trash away. So you see the garbage collector as something similar with that. So the garbage collector in Dart works in 2 phases. The young generation and then the old generation parallel max sweep. So I think I have some examples. No? Okay, so this is an example of a short-lived object, and this is so. For example, you want to call an API, and you fetch, you create a variable called response, fetch API response, and the string username, int score, and all. So once this particular function is done, these variables are no more needed. So the garbage collector comes and it cleans them up. I think that's done by the what's the first one? The young space scavenger. But then we have long-lived objects, which is like, let's say a user session, for example, or a user object that you're going to use throughout the app. Those are like examples of long-lived objects, and these ones are basically collected by the old generation. Okay, optimization. Okay, yeah, so the DartVM does some things to optimize the code for production. And first we have function inlining, we have dead code elimination, and constant forwarding. So this is an example of function inlining. So here we have this function. For inlining, we call it like this. But the DartVM basically kind of removes the function and just translates it to this. So this is what function inlining looks like. And then we have dead code elimination. So for example, this is a calculate function that takes in x and then multiplies it by 5. But this code, I'm not sure why anyone would write code like this, but this particular code here is a dead code. It's never going to get executed. And your application does not need this code. So the DartVM is going to go ahead and clean it up for you. And yeah, constant forwarding. So you have a constant, rather than writing 200, for some reason you write 10 times 20. The DartVM also does this, just folds it into one. Okay. DartVM in Flutter. So the DartVM is at the core of how your Flutter application runs. The DartVM provides features like JIT during development for hot reload and AOT compilation for optimized performance in production. It manages your code execution, memory, performance optimization, and everything. So basically, DartVM is responsible for almost everything that is happening under the hood. And DartVM, I don't think, DartVM in Flutter Web doesn't really exist because your Dart code on web gets compiled to JavaScript before deployment. Yeah, so quick conclusions. Your DartVM powers Dart execution with JIT and AOT for performance and flexibility. It's a core pillar behind Flutter speed, auto reload, and consistency. That is open source and contributions are welcome. Yeah, I think that concludes my little presentation. If you have any questions, I'm open to them. Any questions? Seems everyone understood that.
I'll ask a question. When you're talking about the isolate and you're saying, I guess comparing it with the image, like downloading an image, I guess what's the value of using the isolate versus just kind of having that be in like a future builder or like an async kind of builder of its own?
Yeah, my example with the isolates was more of maybe you're downloading a massive file rather than an image. An image would probably download quick, but let's say you have a file that's, I don't know, maybe 5 gigs or so, and you need to download it. It's very heavy computation, and it can basically make your UI lag if you use a future builder or you do it on your main thread. So the memory that the operating system or whatever assigns to your mobile application is not a lot. Everything is managed by the operating system. So if you're trying to do heavy computation on the main isolate, the main thread, it's going to get really janky, if that's the word. That's why you need to move it to a different isolates, right? And then send back the result to the main isolates. So it's always good to break down heavy computation and throw them in a different isolates, basically.
Thanks.
Other questions?
Follow up on the previous question, because Future already spawns a new isolate because the I/O kind of handles it like OS, right? So it wouldn't really make difference if it's a 5
Can you come again? I can't really.
It wouldn't really make a difference if it's a 5 gigabyte size file or a really small image because it already spawns a new thread, whatever the OS handles, because it's an I/O operation, right? So it wouldn't lag the UI even if it's a huge file.
I don't think that's an I/O function.
I mean, the OS handles it, like a network event is like loading a file.
I mean, yeah, but if you're copying a file and pasting the file, probably that's an I/O, but you're downloading the file.
Okay,
It's
that was
not
just
really
the follow-up question. My other one was, do you have any use case for micro tasks? Because I was thinking sometimes and I never really actually had actual use case, like if you have anything. Just curious.
Yeah, that's actually a very good question. I would say maybe if you need to clean up some resources before you perform the event loop performs the next task, that would be a very good use case for microtask. I've never really used it because I've not seen a use case either, but I'm pretty sure, yeah, that would be a very good use case.
In case anyone has ever used them, you can tell me more. Curious. Okay, thank you.